Hello everyone, this is Jiacheng. I'm recording this for ECE6303 probability, and this is homework 11. And let's look at our last question of this semester. This semester passed very fast, and we have learned a lot about stochastic process and probability, basic probability properties. And basically, let's look at this question. This question is not to think about like the following function. We have 3 functions here, and each function we need to think about the represent or not. Like we need to think about the stationary stochastic process. Basically, what we need to do is to do the same thing as above, to write down the autocorrelation and the power spectrum density. So these two formula will help us to evaluate these 3 functions. And basically, these 3 functions also have very friendly property for the Fourier transform, and we can basically transform between Fourier domain and time domain. So it will help us to solve this question easily. Basically, the spectral density function, we need to think about the integral part. And I think that's all for the thinking part. Let's do the solution part. So for the second part, we need to first write down the autocorrelation function, because E minus absolute value of e to the absolute value of minus v is basically just like this shape here. So we know that it's even, and we know that the 0 represents the maximum of this function, and we also know that this the e to the power minus absolute value of v can transfer to Fourier form like this, which is non-negative, and it can also represent a power spectrum, because this one is greater than 0, and because as we already have the property of the spectrum density function and the autocorrelation function, we know the property of these 2 parts, and we can formalize the standard for validate whether this function is a autocorrelation function or a power spectral density function or not. And the second part, we need to think about this function. And this function, we also know that it's positive definite, and also that we know the maximum value of this one is 1, and it's also even. We can transfer it to the Fourier part, and we know that it's a triangle, which is non-negative, so it can be represented as a power spectrum density function, as we know that this part is greater than 0. And the last part, we need to think about this function here. This function is basically just like a square signal. When the v is less than alpha or minus v is greater than alpha, it will be 1, otherwise it will be 0. It can not represent an autocorrelation function. So basically, the problem is that the Fourier transform of this part is 2 sine alpha omega over omega, which is not non-negative. This will turn out that it will not be the autocorrelation function. But it can be represented as a power spectrum because this function is greater than 0. And I think that's all for this question. We need to remember the two properties of the autocorrelation function and the power spectrum. So the first thing is that autocorrelation requires us to have the even function, and it also need to be non-negative definite. For the power spectrum, we only require it to be greater than 0. That's all what we need for to verify whether it's a power spectrum or not. And that's all for this question. Thank you all for listening. Bye.